Okay, I should be recording. Hello, I don't know if you can see me. I'm up in the corner, but I don't think it actually shows me. I wanted to kind of go through the basic concepts for the last quiz and then something kind of related to it, which is the stuff we did in parabolas within class. So you're gonna see this. You can do it along as well, but I'm gonna kind of jump around a little bit because I'm gonna do the stuff related to circles first. So one of the skills that we've learned is how to make a perfect square. And the idea is, let's see if I can annotate this thing. Yes, I can annotate. So, if I've got x plus 3 times x plus 3, and I multiply that together, my first two terms get to multiply together. I get x squared. My outer terms get added together. It's 3x. My inside terms get added together. It's 3x. And my last terms get multiplied together. It's 9. And that's x squared plus 6x. Plus 9. Okay, so there is lots of stuff that led up to that, but the basic idea is that we actually learned after many, many tries, if you take this number, divide it by 2, and then square it, it will always give you this number if it is in fact a perfect square, which is what this is. This is x plus 3 times x plus 3, and we can physically model that this way with a little x plus 3, some number I don't know, and x plus 3, some number I don't know. So whatever this number is x squared, and I've got 3 of those numbers and another 3 of those numbers, and then 9 total. So that's what is called our area model. Anyway, so once again, this is called a binomial square. Nomial square. And this over here is called a trinomial square because there's 3 of them, but they're both square terms. In fact, they're both the same. These are interchangeable, and we should be able to get from one to the other. So knowing this pattern of whatever this middle number is divided by 2 squared will give me the last number. That's also the way I can check if it's a perfect trinomial square. Allows me to rewrite it in this form. And we'll notice also that this 3 here is exactly that 6 divided by 2 there. So actually the problem I've got here is identical to what I just did. So let me show you that. Let me clear all this. You'll notice if I put a 9 in there, it will check this. Okay. But since it's the same problem I just did, let's pull up another one. Okay. So do that. So, and you can also, this is a plus -4. You could also think of this as x squared minus 4x plus something. So I got to figure out, oops, this should be no, minus 4x. So I got to figure out what is that missing number. And that's what I'm going to type in. I just did that for an example. So what is that missing number? Well, half of -4 is -2, and -2 times -2 is a +4. And so that's that. So you can try one of those on your own in the link that I provided. Now notice this is saying, oh, that x squared minus 4x plus 4 can also be written as x minus 2 squared or x plus -2 squared. Okay, so that's actually important because on the next page it says, oh, can you rewrite this? And once again, first of all, this is a perfect trinomial, and the reason I know it's a perfect trinomial is because this is x squared plus -12x or minus 12x. I can write it either way, plus 36. If I take half of this thing, -12 over 2, it is 6, and then I square it. Oh yeah, that's 36. So this is a perfect trinomial. The question is, how can I write it like x plus something or x minus something? Well, our pattern was whatever this number inside the square will do it. So this was -6. So like, oh, that's x minus 6. Now you have to be careful here because of what this says. It says x plus something. So x minus 6, that's the same as x plus -6 squared. We got to pay attention to the directions. So the number we're looking for there is a -6. Right? So that's -6. And you might get a different problem. No, let me make sure that's right. No, and notice also, like if that had been a plus, it would have been a +6 because once again, it's half that number. And these things work for different reasons, but mainly once we figure out the pattern, we usually just remember the pattern and forget like, why does that work? All right. The other thing that we learned, we spent many days on, is we learned that if a circle is written in the form like x minus 1 squared plus y minus 2 squared equals 9. If it's written in this form, which is called the standard form, then the center is, in this case, 1 and 2, and the radius is the square root of this number. So it's 3. And sometimes we'll rewrite that as 3 squared to make it obvious. Like, oh yeah, the radius is 3, it's not 9. The other weird thing that can happen, so notice these are minuses. This is just the pattern. So wherever, if I've got minus and minus, wherever, whatever numbers I put in there, this thing will move it around, okay? So if this happens to be a plus, this is no longer a 2. Y plus 2 is not the right format. This needs to be written as y minus something. Well, how can I rewrite that? I need to make it equivalent. Well, y minus a minus 2 is the same as plus 2. So if it's written this way, I have to mentally think, oh, this is really not written the right way. It should be minus a minus 2. So this becomes a negative. So we can use that up here. So up here, we're like, oh, this isn't the correct format. That's a 6. So the center here must be 6. I'm going to switch back out of this. Center must be 6 for the x. And y minus a minus 10, which also could be written as y plus 10, but I made it easy in this first one here, minus 10. And then the radius is 36. So that's not the radius, that's the radius squared. So the radius is the square root of 36 or just 6, okay? All right, let's go to the next one. So this is related to a parabola. It's a different shape, but notice kind of, oh, that kind of looks the same. So we'll come back to that. Let's go to the next one. Okay, same kind of problem. I'm on slide 5, I guess. This is kind of written the same way, minus 6. Oh, but they didn't write this the right way. This is y plus 10. I need it to be minus. So this is really minus a minus 10, which is why my y is a negative 10. And this is square root of 34, which is probably 5.9 maybe. Oh yeah, that checked. I could also do SQRT and 34, and that gives me another problem. Okay. All right. So this is kind of related to that. I'm going to go parabola. Okay. So let's clear out some of my annotations here. All right. So this is not quite written the right way. It's close. It's not written in the annotate. It's not written as x plus minus something squared plus y minus something squared equals some number. But it's close. I've actually got everything kind of arranged there. So I'm like, oh, okay, I can tell what number this was. This was, I took my negative 12 divided by 2. That gave me negative 6, and I squared it. Oh yeah, that's already a perfect square. And then the way I figured this out, oh yeah, it's just this number. So this is a minus 6. We'll figure it out if I'm right in a minute. And the same way, this one right here, half of 20 is 10. That squared is 100. So that is a perfect trinomial already. But then this number is going to be a plus 10, or I can write it as a y minus a minus 10. Either way, that's more helpful. Same thing. And then this is all equal to 36, which is conveniently a square already. So once again, my radius is the square root of 36. All right, so I think if I did all these right, this should be 6. This should be negative 10. And this should be 6. Woohoo! All right, what else? Kind of the same thing for that. And okay, last one. Well, and then I'm going to go back and do parabolas real quick. Let me clear all this. All right, so this one's not written right at all. This doesn't even close. The last one was like x squared plus something, and I'm actually going to move these things around here. I'm going to say that's minus, I see a minus 12. I'm going to get my x's together. And then there was a third number before that had been added in. And then y squared plus 20y. And there was another third number that had been added in. And they've got all this equal to negative 100, which seems wrong to begin with because I can't do square roots of negatives. So these, I don't have the perfect squares yet. Like in the previous problem, I already had 3 numbers and they were already set up, but I can turn these into perfect squares. I can say, oh, well, this is, minus 12 divided by 2 is 6. That squared is 36. So I'm, oh, okay. If I add a plus 36 there, that is now a perfect square. So I can say, oh, well, that's x minus 6 squared. Once again, the 6 came from minus 12 divided by 2. Those are equivalent. Okay. Now, the only problem here, I can't just add that number here magically, not without screwing up my equation, unless I add the same number to the other side. So I'm going to add 36 over here, kind of squeeze it in. Now that's balanced. These are now equivalent equations. This is what I started with. I just added 36 to both sides, but it allowed me to rewrite this in standard form. All right, same thing here. So half of 20 is 10. That squared will be 100. And then that means I can rewrite this as y plus 10 squared or minus a negative 10, either way. But once again, since I added 100 there, I got to add, that makes it easy. That negative 100 and positive 100 cancel each other out. So I've just got 36 left on this side when I combine all those like terms. Now this is easy. Now this is written the way I want to. Once it's written this way, I can say, this has got to be 6. This has got to be a negative 10 because minus a negative 10. And this has got to be 6. Oops. 6. Okay. I'm just curious. It seems like I got the same 2 problems in a row. I did. I might need to fix that. Okay. Okay. Anything else? Nope. That's just some practice. Okay. So let's go back and talk about how this works with parabolas. It's kind of the same idea. And back on slide 4. Yeah. Okay. So this is just a different shape. Let me clear out my annotations. All right. This is just a different shape. This is a parabola, and generally a parabola is y equals x squared. But this thing can move around the screen. And if I move it around the screen and I write it in such a way that it's written like y minus 1 equals x squared, x minus 2 squared, kind of the same thing. This tells me, oh, what's called my vertex, which is right there, that 0, 0 point, will move to the right 2 because I'm subtracting 2 from the x. So this is just like the circle. So my new vertex, as opposed to my center, my new vertex is at 2 for the x value. And for the y value, it's a 1. And once again, our pattern is minus. And this is just a pattern somebody figured out. And we're like, oh, it's kind of the same for the circle. The only difference is there's no exponent here. So I don't have to worry about that. Okay, so this is 1. The only a little confusing part about this is because here we have the x's on the right side of the equation. You might get these backwards. It's easy to grab the 1 first and the 2 and reverse those. All right, so this is already written in that form. So this is telling me that the y has, so I'm going to do the y, see the y's over here. And in fact, if I accidentally put it in the wrong place, I think it'll tell me negative 10. Oh yeah, are you getting your x and y's mixed up? Yes, I am. Okay, so my negative 10 actually goes over here. And my 6 goes here. Okay, so that is the same shape. It's just moved over 6 and down 10. And that's one way I can write this way thing. It's not the only way, but it's one way to write this. We explored some different ways to write it in class, but this is just kind of, it's kind of the same idea. So let's go over to this. So once again, this is kind of the same thing. The only difference is, notice I got the plus there. So what's that going to change? Well, our pattern was, it's got to be minus. So this is really like y minus a minus 8. So this becomes negative 8. This moved over 2. And notice the shape hasn't changed at all because there's no scale factors in here. I actually could put a scale factor in here and stretch this thing out. But right now, I'm just transforming. It's just like the circle. The only circle we were able to control the radius. But in this thing, we don't have anything to control the shape yet. It's always exactly the shape. Okay. So let's jump to here. So this is basically that form with one exception. And the one weird thing that's going on here is, well, I don't have y minus on the left side. I really want, y minus something here. Well, I got that 11. If I minus 11 from both sides, I'll get y minus 11 equals x minus 2 squared. Now it's written the same way. Or some people just like writing it this way and just realizing, oh, whatever I'm plussing, that actually is my number. Notice it's a minus when we write it on this side, so it's what I'm minusing. But when I write it this way, it's what I'm plussing, in which case kind of your x's and y's, you got to keep straight, like the rule's different if it's written this way. And it often is written this way. This is a more convenient form sometimes. Notice also now the x and the y, the 2 and the 11 are kind of in the right order here. So that also makes it easier, a little easier to get the right answer. Okay, so that's just a trick, and this moved off the screen. That's fine. Is that it? Is there one more? I think there's one more. There's one more. Okay, so let me clear all this up. All right, so this doesn't look like anything we had before. This, I want this to be y minus something equals x minus something squared, and then I can tell you exactly where this thing moves. So what is this thing right now? It's y equals x squared. I'm going to write it as minus 20x plus 94. So we're going to kind of do the same trick we did before in the circle. We're going to say, well, if I can complete the square over here, I can get it to this format. So I'm going to do the same thing I did with the circle, kind of. I'm going to get rid of the 94 because it's kind of in my way. I'm going to bring it over here. So y minus 94 equals x squared minus 20x. And then I'm going to say, okay, what would complete the square there? Well, half of negative 20 is negative 10, and I square it, so that's 100. So now I can rewrite this. Oh yeah, this is x minus 10 squared. And the only thing I might forget here is, since I added 100 to this side, this was a new number that I just introduced into my equation. I got to keep my equation balanced. So I've got to add 100 over to this side. So those two are like terms. Negative 4 plus 100, that's a plus 6. And so now I think, oh, once again, it's a minus, like just same as the minus 6. I can say, oh, okay, my x value is 10. And my y value should be a negative 6. Woohoo, got them all right. And I think that's everything. Yep, that's just some cool patterns at the end. You can play around with this. All right, let's see. I'm going to stop sharing. Hopefully that all recorded. Ciao. Hopefully come in and retake this if you weren't happy with your score.